A little over 40 years ago, humanity sent 2 maps of Earth's location into space, which were attached to the exterior of 2 spacecraft. Now, both spacecraft are the farthest artificial objects from us. Today, the Voyager probes are located at the edge of the solar system, continuing their endless journey. If these probes ever encounter extraterrestrial intelligent civilizations and decipher the information on the plaques, it will not only reveal when the spacecraft left their home, but also point the way to our small and cozy world. It would be ideal if this civilization turns out to be peaceful and friendly. However, what if these sentient beings prove to be hostile? What if the potential Voyagers pose a threat to all life on Earth? Traditionally, people's opinions on this matter are divided into 2 camps. Some argue that it is extremely dangerous, and humanity should not have sent out such information, potentially exposing us to unknown risks. Others believe that the chances of encountering hostile beings are slim, and the scientific and cultural value of potential communication outweighs the risks. There is also a third category of people who do not share the opinions of either the first or the second group because they simply don't care. They are indifferent to the whole discussion. However, it's boring and uninteresting to talk about them, so let's focus on the first 2 opposing opinions and examine each of them in more detail. But before that, it would be good to understand what this map actually is, located on board Voyager. It's not the kind of map we are accustomed to, with north, south, west, and east as familiar markers. Instead, pulsars are used as markers. Pulsars are essentially rapidly rotating stellar remnants. They have existed for many millions of years, and each pulsar has its unique pulsation or flickering pattern, which can be used to calculate the position of objects in their vicinity. The famous astronomer Frank Drake, along with the equally famous scientist and writer Carl Sagan and the rest of the team, prepared golden records. These records were created by Drake and contained cosmic landmarks. These golden records, placed on Voyager's spacecraft, indicated the location of Earth in both spatial and temporal coordinates. But let's go back to pulsars. Why were they chosen, and why will extraterrestrial civilizations be able to decipher the coordinates of our world correctly because of them? Earthly time measurement would be meaningless because it is based on the rotation of our planet around the Sun. Another complication arose with the spatial coordinate system in space. No one will find us based on directions like up, down, east, or west. Even the stars change their astronomical timescale over time. An explanation like the second star to the right, then to the left, and straight until morning won't help those who may discover the probes, say, 1 billion years later. By the time the message reaches its recipient, such as the star Betelgeuse, which could serve as a coordinate point, it may no longer exist. That's why pulsars, discovered in 1967, were chosen. These super-dense dead stars act as excellent beacons in both spatial and temporal coordinate systems. They have very long life cycles that can last from tens of millions to possibly billions of years. Each pulsar is unique, and they rotate incredibly fast and emit pulses of electromagnetic radiation, which makes their behavior similar to that of a lighthouse. By calculating the delay between these pulses, astronomers can determine their rotation speed with incredible accuracy. Over time, the speed of pulsars slows down, sometimes by billionths of a second per year. By comparing the current rotation speed of a pulsar with the speed indicated on the discovered map, intelligent life could determine how much time has passed since the map was created. Drake hypothesized that if these beings can understand what pulsars are, they would definitely know their location in the galaxy. Using the obtained map, they could approximate the launch time of the spacecraft and trace its trajectory, ultimately leading them to the Sun. At that time, there wasn't much debate about the pros and cons of contact with extraterrestrial intelligence. Why? Because when Voyager 1, which is essentially Voyager 2, was launched, scientists had no idea if there were other planets beyond the solar system. It was all speculation. Therefore, no one really speculated about the possibility of intelligent life elsewhere. However, just over 10 years later, the Hubble Space Telescope appeared, and we now know that planets are quite common in our galaxy. The percentage of intelligent life on these worlds may be similar to our Earth. This revelation has sparked a strong desire to send targeted radio messages towards promising star systems. Among scientists, other prominent individuals, and especially our viewers, debates have intensified about whether our decision was wise and whether it would be better to simply continue listening to the cosmos rather than striving to be heard. However, for Voyager, it is already predetermined. They are there, they are flying, carrying a map of our home, and if someone is out there, they will definitely be able to find us. Therefore, we can only talk about the majors in hindsight. We cannot bring them back, and we cannot catch up to them. And why did we get fixated on Voyager? There are also Pioneer 10, Pioneer 11, and the New Horizons spacecraft, all carrying messages for extraterrestrial civilizations. If we rephrase the question and formulate it as whether it is worth sending signals with information about Earth into space, it raises more food for thought about the essence of it all. Let's ponder if it is dangerous or not. For example, the late Professor Stephen Hawking warned back in 2010 that humans should remain as quiet as possible because otherwise, advanced aliens interested in Earth's resources could take over the planet. He likened the situation to Columbus's landing in America, which did not turn out well for the Native Americans. To some extent, this is true. However, Dr. Douglas Vakoch from the SETI Institute in California has a different perspective, as this is precisely the institute dedicated to the search for extraterrestrial intelligence. Some believe that we should refrain from powerful transmissions, fearing an alien invasion. If these views spread, humanity would become isolated, avoid exploration, and minimize risks at all costs. Well, that's also true, isn't it? But can we not send signals directed at any stars or exoplanets? Not sending them into space is not possible because our planet has a constantly expanding, easily detectable radiosphere. It carries information about our civilization, such as the radio signals generated by television, cell phones, and satellites. Their presence can be easily detected from space, even though radio signals weaken the farther they are from their source. The entire question lies in their detection, which depends on the characteristics of the receiving equipment. Ordinary radio broadcasts can be detected if someone is actively searching for them, and hostile civilizations eager to attack someone will easily determine the location of Earth and the presence of life on it. Or, let's assume that extraterrestrial civilizations exist nearby. Let's take a look at ourselves from their perspective and try to answer the question, are we interesting to them? To answer the question of whether we are interesting to them, we occupy all our free time with blatant brawls. Historians once created a remarkable graph in a logarithmic scale, with time on the axes, starting from 6,000 years ago when the first writing appeared, and up to our time. They measured the duration of wars for each year, and it turned out that in the entire span of 6,000 years, there were only 3 months of peace when there was no war on the planet. A civilization engaged in self-destruction is not of interest to anyone, except perhaps to observe from a distance without making contact, just as we do when we observe fighting beetles in a jar. Or let's say that for an extraterrestrial civilization, their intentions are indeed aggressive, confirming the fears of Stephen Hawking and others. Why would they come here to engage in warfare and expend energy and resources? What valuable resources does Earth possess? It is unlikely that they would come here for oil, water, or anything else. Perhaps we humans ourselves are the valuable resource. But enslaving us for hard labor doesn't make sense. It's not beneficial at all. Humans are susceptible to illness, fatigue, and need food and drink. Moreover, they are fragile and cannot work for extended periods. If a civilization is truly intelligent, it would be easier for them to build an army of robots to handle laborious tasks. But in reality, if there were many such civilizations, whether good or evil, it wouldn't matter. This means that they haven't developed such ships and won't come, and we will never travel anywhere. It's all due to the tremendously vast scales of space. For example, we received a signal from a civilization living at the center of our galaxy. The signal from their council takes 30,000 years to reach us. We urgently send them a response, requesting knowledge about the universe, equations of quantum gravity to be placed in their library, and everything else. But even if they receive the signal, it will take another 30,000 years for their response to reach us. So for those who receive it, it becomes pointless. And if we consider intergalactic distances, the Andromeda Galaxy, the closest one, is 2 million light-years away. This means we will receive that knowledge in 4 million years. Let's assume that in a galaxy with 100 million stars, there are millions of civilizations similar to ours. But some of them emerged 100 million years before us, while others will emerge 100 million years later. What would we even talk about with civilizations that are 100 million years older than us? We would be like insects or microbes to them. Let's say we send them a signal, they receive it, and from their perspective, they see it as something trivial. In conclusion, the likelihood of the maps on board the Voyagers reaching the shores of extraterrestrial civilizations is extremely low. The spacecraft are not aimed at any specific star. They are simply flying. If extraterrestrial civilizations have powerful enough radars, they might be able to detect Voyager from afar. But in that case, they would have already detected signals from our planet, according to our channel's opinion. The Voyager spacecraft, just like the Pioneers and New Horizons, pose no danger to Earth. Instead, they are a reason for pride. Imagine that those images, sounds, and maps of planet Earth can endlessly and imperceptibly float through space. Moreover, they will likely outlast us. Humanity might not exist, but at some beautiful moment, these artifacts made by human hands could be the last remnants in the universe. In the past, Pluto was considered the 9th planet of the solar system, and astronomers actively discussed the hypothesis of a 10th planet. However, when Pluto was later demoted, astronomers began searching for the 9th planet once again. If the 9th planet truly exists, where is it and what kind of planet is it? What do we currently know about it? Let's get started. The planet X. Problems related to Uranus and Pluto. After the discovery of Neptune, the question of whether there exists a giant planet beyond Neptune's orbit troubled researchers. When you think about it, everything originated from the orbit of Uranus. It didn't match the calculations that were possible at the time, and this discrepancy led to the discovery of Neptune. However, it was soon realized that the mass of Neptune did not match the mass that would have been exerted by Uranus. The most diligent explorer of the planets beyond Neptune's orbit, that is, the entire outer solar system, was Percival Lowell. He searched and wandered for a long time, and in the end, didn't glimpse it, but left behind many valuable calculation results. After Lowell passed away in 1916, his calculations seemed to be fading away. In 1930, Clyde Tombaugh discovered Pluto, which was initially considered a very large celestial body. According to the initial calculations, Pluto had a diameter of about 8,000 kilometers, and its mass was similar to that of Mars. If an object of this size had mutual gravitational interactions, combined with the gravitational interaction of Neptune, it could explain the shape of Uranus's orbit. The enigmatic planet appeared to have been discovered, but not everything ended smoothly. The accurate mass of Pluto was constantly updated, and it even decreased each time. After the discovery of its moon, Charon, in 1978, researchers finally found the final value. As a result, Pluto turned out to have a mass smaller than not only Uranus, but even some large moons in the solar system. Even the moon itself had 6 times the weight of Pluto. So, the mystery of an unknown planet blocked the path of researchers, and many of them returned to what Lowell was doing 70 years ago. At that time, the existence of Planet X was evident, and many researchers believed it had been confirmed by calculations. The rest was just waiting for its discovery. Some researchers speculated that the planet they were looking for would have a mass similar to that of Mars and would be in the same region as Pluto. Other researchers guessed that the planet would have a much larger mass than Mars, but would be much farther from Pluto. Either way, they continued to uncover the entire enigma through numerous discussions. Researchers from both sides were greatly disappointed when Voyager 2 reached Neptune in 1989, and, based on the data collected by the probe in 1992, the mass of Neptune was recalculated based on the data. Researchers were greatly disappointed. It was found that there was an error of about 0.5%, and that happened to be the mass of Mars. It was the remaining piece of the puzzle, the mysterious planet. With the accurate mass of Neptune known, researchers recalculated the gravitational effect of Neptune on Pluto's orbit. Surprisingly, the anomalies disappeared. The calculated results matched the actual observed results, indicating that there was no need to consider a 10th planet. Thus, Lowell's hypothetical planet problem was resolved. But our story doesn't end here. New discoveries and new problems arose. In the years following the demotion of Pluto, the 9th planet wasn't a topic that readily came up among researchers. However, as time passed, more and more was learned. It's too early to conclude the story. In 1992, the exploration of the entire outer solar system began, revealing that the solar system doesn't end with Pluto. The most notable discovery among the newly found objects was Sedna, a dwarf planet with a diameter of about 1,000 kilometers. It had a highly eccentric orbit. The passage of time on Sedna during one rotation around the Sun is slightly shorter than 11,500 years. During its long journey, Sedna moves more than 900 astronomical units away from the Sun and gets as close as 76 astronomical units. The long elliptical orbit is not known to exist apart from the known comets. Another notable dwarf planet with a significant difference between its perihelion and aphelion distances was discovered, 2012 VP113. It moves about 446,000 astronomical units away from the Sun and gets as close as 80.6 astronomical units. Researchers have proposed various hypotheses to explain the factors that greatly elongate and distort the orbits of these dwarf planets. According to one theory, the Sun may have an unknown brown dwarf or a dark red dwarf as a partner celestial body. The distance between that star and the Sun could be very large, and we may not know exactly what kind of star it is. A good example that demonstrates the existence of such a star is Proxima Centauri, the closest neighbor to Earth in the Centaurus constellation. This star orbits around the binary stars Alpha Centauri A and Alpha Centauri B, located more than 12,000 astronomical units away from them. The hypothesis of an unknown partner star for the Sun is quite intriguing, and if you're interested, we can explore it further in another discussion. But for now, let's return to the hypothesis of a distant planet that can explain the peculiar elliptical orbits. In 2014, based on the calculations, researchers reached the conclusion that there is no unknown celestial body within a radius of 26,000 astronomical units from the Sun with a mass comparable to or larger than Jupiter, or a celestial body with a radius of 10,000 kilometers comparable to Saturn. However, there is still room for smaller objects with masses below that of Neptune. According to calculations by researchers, there may be a planet with 2 or 3 times the mass of Earth, orbiting around 500 astronomical units away from the Sun. If the mass of this object is larger, equivalent to 15 Earths, the distance from the Sun would be around 1,000 astronomical units. In both cases, considering the potential influence of smaller objects, the actual observational results can be explained. In the same year, astronomers noticed that 6 dwarf planets, including Sedna and 2012 VP113, in the outer regions of the solar system, orbit more than 250 astronomical units away from the Sun, have similar orbital characteristics, and move in nearly the same direction in space. This suggests that these objects are being shepherded by some celestial body and influenced by its gravity. However, despite all this, the enigmatic planet has not yet been discovered. Researchers speculate that this planet may be very dark. Interestingly, a similar hypothesis existed for Pluto as well. Astronomers considered the possibility that Pluto might be larger than expected. Recently, Chinese astronomers made a novel proposal. Instead of searching for the planet itself, they suggested looking for its satellites. An object with that mass could attract celestial bodies of about 200 kilometers in size from the scattered disk or the outer cloud, at least 20 of them. Such objects can be observed if the location is known. If successful, it would be an unprecedented event where the satellite of a celestial body is discovered before the body itself. With this, today's video comes to an end. My hypothetical planet would probably have a dark and dim appearance. if its mass is similar to Earth's, its surface would be solid and completely covered in ice. In the planet's sky, the sun would appear small, similar in size to other stars. There would be hardly any brightness greater than that of a full moon visible from Earth. The surface would be covered with frozen gases like nitrogen, carbon dioxide, or methane. There would be no significant heat transfer to melt the ice from the sun. If my hypothetical planet were a giant planet like Neptune, it is difficult to even imagine what kind of celestial body it would be. So we can only hope for new discoveries in the future. Many of you are well aware that the largest planet in our solar system has a vast array of satellites, each of which can be intriguing for research purposes. Among all of Jupiter's satellites, the so-called Galilean satellites, Ganymede, Callisto, Europa, and Io, are considered the most prominent and well-known. They were discovered in 1610 by the renowned astronomers of the Middle Ages, Galileo Galilei. Ganymede is the largest satellite not only of Jupiter, but also in the entire solar system. In terms of size, it is 8% larger than Mercury, although it is slightly less massive. In June 2021, a research mission took place within 1,000 kilometers of Ganymede, and scientists are still deciphering what this encounter can tell us about this peculiar world. 2 previous missions captured images of Ganymede, the largest satellite in the solar system. These were the Voyager 1 mission in 1979 and the Galileo spacecraft in the mid-1990s. However, some of these images were taken from less than ideal angles, leaving large white spots about which scientists had no information. Technologies have significantly improved since the launch of those missions. Therefore, scientists were thrilled when the Jupiter explorer Juno revealed the cratered surface of Ganymede in exquisite detail and observed shimmering polar auroras extending between Ganymede's poles and equator. These images unveiled numerous new features on Ganymede's surface, including impact craters up to 100 kilometers in diameter. We missed several truly massive impact craters that we simply couldn't see in Voyager's data, scientists declared. This should serve as a cautionary tale against attempting to map a world based solely on one image and one lighting angle. We missed this large 100-kilometer-wide crater that is clearly visible in JunoCham's data, and we missed another slightly less obvious one, measuring about 110 kilometers. The images also revealed several smaller craters with widths ranging from 40 to 50 kilometers, and numerous features that, according to scientists, could be the result of volcanic activity on Ganymede. We discovered features resembling calderas similar to those previously seen in other parts of Ganymede. Calderas are volcanic craters that were likely formed by cryovolcanoes erupting frozen water and gas from beneath the moon's surface. The quantity of these features observed in Juno's images indicates a much more intense volcanic activity on Ganymede than scientists previously expected. In fact, this increases the overall count of goat-like features we have discovered across the moon by 30%, scientists stated. This certainly leads us to think that we have underestimated them so far, and there may be many more on Ganymede. When we obtain new data, Ganymede is not only the largest satellite in the entire solar system, but it is also the only known satellite with its own magnetic field. Changes in its magnetic field led scientists to conclude that Ganymede must have a massive subsurface ocean of salty water, with depths of up to 100 kilometers, concealed beneath an ice and rock crust up to 150 kilometers thick. This ocean makes Ganymede one of the prime candidates for the existence of primitive life forms. Being about 1 million kilometers away from Jupiter, Ganymede is surrounded by the magnetic field of this gas giant, as well as its immense gravity that attracts passing asteroids and comets. The interaction between Ganymede's and Jupiter's magnetic fields produces vibrant polar auroras on this satellite. Ganymede's polar auroras are the only such phenomena ever observed on a moon. They were discovered in images obtained by the Hubble Space Telescope, but the recent flyby of Juno allowed scientists to gather more information about these shimmering spectacles. Now, we have been able to see the precise locations of auroral emissions, said one of the researchers at the conference. We were able to see the latitudinal extent of the polar aurora, and we see very sharp boundaries at the polar edges of both auroral ovals, whereas the emissions taper off more gradually as you move toward the equator. Therefore, future models will need to explain this. The end will be the main goal of the upcoming European mission to study the icy moons of Jupiter, whose launch is expected soon, planned for April of this year. Besides Ganymede, this is an automated interplanetary station designed to explore the Jupiter system. It will study the moons Europa and Callisto, and its main focus will be to investigate the presence of subsurface liquid water oceans on these moons. Callisto is a large moon orbiting Jupiter with an ancient cratered surface, indicating that geological processes may be dormant. However, it may also harbor a subsurface ocean. It is unclear if life can exist in the ocean because the surface is very old, so more observations are needed for this large moon. The moon has been the subject of several flybys, including the extended Galileo mission to Jupiter in the 1990s and 2000s. The upcoming mission called JUICE, Jupiter Icy Moons Explorer, will focus on 3 icy moons of Jupiter, including Callisto, to gather more information about their environments. JUICE is expected to enter Jupiter's orbit in 2031. Currently, there is a mission to Jupiter called Juno. Although Juno is primarily designed to observe Jupiter's atmosphere and environment, it has captured several images of Callisto and other icy moons of the solar system from a large distance. In recent years, other icy moons have received attention from researchers due to their potential for life. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, discovered extensive evidence of geysers on its moon Enceladus. Other icy moons include Triton, orbiting Neptune, and Europa, another icy moon of Jupiter. Overall, these moons sustain liquid oceans due to the gravitational pull of their giant planets. The 4 largest satellites of Jupiter, Io, Europa, Ganymede, and Callisto, are also known as the Galilean satellites, named after Galileo Galilei, who discovered them in 1610. All 4 are larger than Pluto. Among them, Ganymede is the largest satellite in the solar system, even larger than Mercury. When Galileo pointed his telescope at Jupiter on January 7, 1610, what he saw amazed everyone. The planet was not alone. It was surrounded by 4 moons. At that time, it was believed that Earth was the only planet with a moon. For 2 centuries, Jupiter's satellites were referred to as the Medicean stars, named after the powerful Italian political family, the Medicis. The discovery had not only astronomical but also religious significance. The Catholic Church supported the idea that everything revolved around the Earth, an idea put forth by ancient astronomers Aristotle and Ptolemy. Galileo's observation of Jupiter's satellites, as well as the discovery that Venus went through phases similar to our own moon, provided compelling evidence that not everything revolved around the Earth. However, as telescopic observations improved, a new perspective on the lunar planets emerged. They were not immutable and perfect. For example, mountains seen on the moon indicated that geological processes were occurring elsewhere. Furthermore, it was discovered that all planets revolved around the Sun. Over time, satellites were found around other planets, including additional satellites around Jupiter. The Medicean satellites were renamed Europa to avoid confusion in the mid-1800s. Callisto, approximately 4.5 billion years old, is roughly the same age as Jupiter. It is the most heavily cratered object in the solar system, with minimal geological activity on its surface. The surface has not changed significantly since its formation by the first impacts 4 billion years ago. Callisto is the farthest of the Galilean satellites, orbiting Jupiter at a distance of about 1,880,000 kilometers. It takes approximately 7 Earth days for Callisto to complete one orbit around the planet. It also experiences less tidal influence than the other Galilean satellites because it orbits outside Jupiter's main radiation belt. Callisto is tidally locked to Jupiter, always showing the same face. With a diameter of 4,800 kilometers, Callisto is roughly the same size as Mercury and is the 3rd largest satellite in the solar system after Ganymede and Titan. The average surface temperature of Callisto is -139 degrees Celsius. Although telescopes significantly improved during the space era of the 1960s, there was still limited knowledge about Callisto. According to a book from 2004 titled Jupiter, Planet, Satellites, and Magnetosphere, astronomers could tell that the surface appeared relatively featureless compared to Io and Ganymede. Callisto also had a low reflectivity, albedo, and was known to have low density. Astronomers had not observed any signs of water geysers, leading them to conclude that Callisto had a rocky surface. Pioneer 10 and Pioneer 11 flew by Jupiter and its satellites in the early 1970s, but these missions did not provide much new information about Callisto, apart from what ground-based telescopes had already shown. It was the Voyager missions in the late 1970s that truly revealed a different picture. Density and temperature measurements of Callisto were refined, and high-resolution surface images revealed details as small as 1 kilometer per pixel. In other words, the resolution was sufficient to detect impact craters. In reality, Callisto was heavily cratered compared to other moons. Some consider Callisto to be the most unexciting object of its size in the solar system. For more detailed observations, we had to wait until 1996 when the Galileo spacecraft made its first of 12 flybys of Callisto. Multiple passes by Galileo and higher resolution allowed for much more information to be gathered about Callisto than before. Large portions of the surface were mapped, revealing a tenuous atmosphere of carbon dioxide and evidence of a subsurface ocean. Arguments in favor of an ocean stemmed from two pieces of evidence. First, scientists observed regular variations in the magnetic field around Callisto, suggesting the presence of an electrically conductive layer, which could be an ocean. This indicated that there were electric currents inside the moon stimulated by the planet's magnetic field. This flow had to come from somewhere, leading to the second part. Due to the rocky surface and tenuous atmosphere, a probable explanation was a salty ocean beneath the moon's surface. In 2018, a study of archival images taken by the Hubble Space Telescope in 2007 showed the influence of Callisto on polar auroras in Jupiter's atmosphere. Jupiter generates polar auroras on its own, but some phenomena occur due to interactions with its four largest satellites, Europa, Io, Ganymede, and Callisto. The signatures of other satellites had previously been detected in Jupiter's atmosphere, but this new study was the first to detect the Callisto effect. Callisto and the other Galilean satellites may have formed with the help of Saturn. A computer model released in 2018 proposed that as Saturn's core grew, its gravitational influence pulled the inner planets of the solar system inward. This process could have provided enough material for the formation of the four Galilean moons. Recent scientific research includes modeling the interaction of Callisto's magnetic field with Jupiter and detecting atomic oxygen in its atmosphere using the Hubble Space Telescope. The research provided further evidence of the existence of a subsurface ocean on Callisto. Other studies focused on aspects such as the potential presence of water beneath its surface, refining the number of craters on its surface, and studying its atmosphere to determine its suitability for life and how it formed. These unanswered questions will be addressed by the upcoming JUICE, Jupiter Icy Moons Explorer mission, which is planned to launch to Jupiter in 2023 and will operate in the Jovian system for at least 3 years between 2031 and 2034. JUICE will primarily focus on Ganymede, but its scientific objectives for Callisto will be similar. This includes searching for layers of an ocean or water reservoir, mapping the surface, studying the atmosphere, and determining the interior structure of Callisto. As Jupiter's fifth satellite, Callisto is the most volcanically active body in the solar system, with its surface dotted with hundreds of volcanoes. Some of these volcanoes emit sulfur plumes reaching hundreds of kilometers in height. This volcanic moon is the third largest and the innermost of Jupiter's Galilean satellites. It is caught in a gravitational tug-of-war between Jupiter and its two neighboring moons, Europa and Ganymede. These tidal forces generate heat, which stimulates intense volcanic activity on the moon. Its surface changes at an incredible rate as volcanic fissures release lava onto the surface, filling impact craters and creating new liquid rock flows. While the exact composition of the satellite is unknown, it is likely composed of molten sulfur and its compounds or silicate rock. Additionally, the thin atmosphere of the moon mainly consists of sulfur dioxide. The age of the Moon is approximately 4.5 billion years, similar to the age of Jupiter. Io, the fifth moon from Jupiter, has an average orbital distance of approximately 422,000 kilometers and completes an orbit around Jupiter in 1.77 Earth days. It is tidally locked to Jupiter, always facing the same side towards the planet. Io has an average radius of 121 kilometers, making it slightly larger than Earth's moon. It has a slightly elliptical shape, with its longest axis directed towards Jupiter. Among the Galilean satellites, it ranks third in size after Ganymede and Callisto, but surpasses Europa in terms of mass and volume. The average surface temperature of Io is approximately -130 degrees Celsius, leading to the formation of sulfur dioxide snowfields. However, the volcanoes on the Moon can reach temperatures of up to 650 degrees Celsius. It is often referred to as a celestial body of fire and ice. When Jupiter and Earth are on the same side of the Sun, the distance to Io can be as close as 588 million kilometers. At maximum distance, it can reach 968 million kilometers. The volcanic activity of the satellite was first discovered by the Voyager missions in 1979. The Moon's volcanism is driven by powerful tidal forces as it orbits Jupiter on an elliptical path. The gravitational force exerted by Jupiter on the Moon varies depending on its proximity to the gas giant. These gravitational fluctuations constantly push and pull the inner part of the Moon in different directions, causing the Moon's surface to bulge by about 100 meters. This movement forces Io's rocks to rub against each other, releasing an enormous amount of heat, about 20 times more thermal energy than the Earth emits. If Io were the only moon of Jupiter, its orbit would likely have settled into a circle long ago. However, the ongoing gravitational interaction with Europa and Ganymede guarantees that this won't happen. The Moon cannot escape this eternal gravitational tug-of-war, resulting in continuous tidal heating. The atmosphere of Io, due to sulfur dioxide, is extremely tenuous at about 1/1,000,000th of Earth's surface pressure. The Moon's orbit intersects powerful magnetic field lines of Jupiter, turning it into an electric generator. It can generate up to 400,000 volts, and in turn creates 3 million amperes of electric current. It then travels along the magnetic field lines of Jupiter and triggers lightning in the upper layers of Jupiter's atmosphere. As Jupiter transforms its magnetic forces, it carries away tons of material every second, ionizing it and forming a donut-shaped radiation cloud called the plasma torus. Some regions are drawn into the upper layers of Jupiter's atmosphere, creating polar auroras. An example of this activity was discovered by the Hubble Space Telescope, which revealed the influence of Ganymede, another satellite of Jupiter, on Jupiter's polar auroras in 2018. Additional evidence of the interaction between the volcanic activity of Io and electric currents controlling Jupiter's polar auroras was discovered in a 2022 study. According to observations from the James Clerk Maxwell Telescope and the Texas spectrograph, Io also has a tenuous atmosphere consisting of sulfur dioxide. This atmosphere freezes when the Moon is in Jupiter's shadow each day and turns back into gas when Io returns to sunlight. Scientists had long suspected the existence of this phenomenon, but it was only after this study, which observed the satellite's atmospheres in the dark, that researchers found confirming evidence. Io was the first of Jupiter's moons to be discovered by Italian astronomer Galileo Galilei on January 8, 1610. He had actually observed the Moon the night before, but couldn't distinguish it from Europa, another moon of Jupiter, until the following night. This discovery, along with the subsequent discovery of 3 other moons of Jupiter, marked the first time a moon was found orbiting a planet other than Earth. Galileo initially named this moon Jupiter Was, but in the mid-1800s, it was renamed Io after a priestess of Hera, Zeus's wife, and daughter of Inachus, the king of Argos in Greek mythology. Zeus, or Jupiter, fell in love with her, but turned her into a cow to protect her from his wife Hera. Another name for her was Juno. Although no dedicated missions have been sent to Io, several spacecraft have flown by Jupiter and observed its moons. The first was the Pioneer 10 spacecraft in 1973, followed by Pioneer 11 in 1974, and later the Voyager probes. Voyager 1 and Voyager 2 made remarkable images during their flybys in 1979. From 1995 to 2002, the Galileo spacecraft conducted multiple flybys of Io and provided us with the closest views of Jupiter's volcanic moon to date. In 2000, the Cassini spacecraft studied Io during its flyby on its way to Saturn. Although there are no specific missions planned exclusively for observing Io, the Juno spacecraft, currently in orbit around Jupiter, will fly as close as 300 kilometers to Io in December of this year, providing valuable information for further study of this volcanic moon. We can look forward to new information about Io's volcanism in December 2023 or early 2024. And don't forget to subscribe to the channel to be the first to receive updated information on space-related topics. Europa, one of Jupiter's Galilean moons, along with Io, Ganymede, and Callisto, was discovered by astronomer Galileo Galilei, who gained recognition for the discovery of these moons, some of the largest in the solar system. Europa is the smallest among the four. However, it is one of the most intriguing satellites. Its surface is frozen and covered with a layer of ice, but scientists believe there is an ocean beneath the surface. The icy surface also makes Europa one of the most reflective bodies in the solar system. In 2012, researchers using the Hubble Space Telescope noticed a possible plume of water vapor erupting from Europa's southern polar region. After multiple attempts to confirm the observation, clear plumes were seen in 2014 and 2016. The researchers cautioned that the plumes had not yet been fully confirmed, but they speculate that water from Europa's ocean is being ejected to the surface. Several spacecraft have flown by Europa, including Pioneer 10 and 11 in the 1970s, and the Galileo spacecraft, which conducted a long-term mission to Jupiter and its moons from 1995 to 2003. NASA and the European Space Agency are planning missions to Europa and other satellites that will depart from Earth in the 2020s. Galileo Galilei discovered Europa on January 8, 1610. It is possible that German astronomer Simon Marius also observed Europa around the same time, but he did not publish his observations. Therefore, the discovery is mostly attributed to Galileo. For this reason, Europa and the other three largest moons of Jupiter are often referred to as the Galilean moons. However, Galileo initially referred to these moons as planets of the Medici family in honor of the Medici family. It is possible that Galileo indeed observed Europa earlier, on January 7, 1610, but because he used a low-power telescope, he couldn't distinguish Europa from another of Jupiter's moons until later. Galileo's observations of Jupiter's moons, as well as his discovery that Venus undergoes phases similar to our moon, provided convincing evidence that not everything revolves around Earth. However, as telescopic observations improved, a new perspective on the universe emerged. The moon-like planets were not immutable and perfect. For example, the mountains seen on the moon indicated that geological processes were happening elsewhere. Additionally, it became clear that all planets revolved around the Sun. Over time, more satellites were discovered around other planets, including additional satellites around Jupiter. Marius, another early discoverer, proposed giving the four moons their current names from Greek mythology. However, it was only in the 19th century that the moons were officially given the so-called Galilean names by which we know them today. All of Jupiter's satellites are named after lovers or victims of the god Jupiter, depending on your perspective in Greek mythology. Europa was abducted by Zeus, the Roman counterpart of Jupiter, who took the form of a perfect white bull to seduce her. She adorned the bull with flowers and rode on its back to Crete. Upon reaching Crete, Zeus returned to his original form and seduced her. Europa became the queen of Crete and bore many children to Zeus. One distinctive feature of Europa is its high degree of reflectivity. The icy crust of Europa gives it an albedo, or light reflectance, coefficient of 0.64, which is one of the highest among all satellites in the entire solar system. Scientists estimate the age of Europa's surface to be between 20 and 180 million years, making it relatively young. Photos and data from the Galileo spacecraft suggest that Europa is composed of silicate rock and has an iron core and a rocky mantle, similar to Earth. However, unlike the Earth's interior, the rocky interior of Europa is surrounded by a layer of water and ice with a thickness ranging from 80 to 170 kilometers. Due to the fluctuations in Europa's magnetic field, which suggest the presence of a conductor, scientists also speculate that there may be an ocean deep beneath the Moon's surface. In this ocean, there could be some form of life. The possibility of extraterrestrial life is one of the reasons why interest in Europa remains high. In fact, recent studies have revitalized the theory that Europa may be capable of supporting life. The surface of Europa is cracked, and many believe that these cracks are the result of tidal forces from the ocean beneath the surface. It is possible that when Europa's orbit brings it closer to Jupiter, the tidal pull causes the ocean beneath the ice to rise higher than usual. If this is the case, the constant lifting and lowering of the ocean may have caused numerous cracks observed on the Moon's surface. Obtaining samples from the ocean may not require drilling through the icy crust if the observed plumes turn out to be actual jets of water. While researchers found evidence in 2012, 2014, and 2016, the true nature of the plumes and why they appear sporadically require further observations. In 2014, scientists discovered that Europa may have a form of plate tectonics. Previously, Earth was the only known body in the solar system with a dynamic crust, which was considered crucial for the evolution of life on the planet. The presence of water beneath the frozen crust of Europa leads scientists to consider it as one of the best places in the solar system with the potential for life. It is believed that the icy depths of the Moon contain vents in the mantle, similar to the oceans on Earth. These vents could provide the necessary thermal environment for life to develop. If life exists on Europa, it may have received a boost from comet deposits during the early stages of the solar system's existence. Icy bodies could have delivered organic material to the Moon. In 2016, a study revealed that Europa produces 10 times more oxygen than hydrogen, similar to Earth. This could make its potential oceans more conducive to life compared to other icy moons. It is possible that tidal heating is not necessary to generate sufficient energy. Instead, chemical reactions could be enough to drive a cycle. In 2013, the National Research Council of the United States published a 10-year recommendation for the Planetary Science Program of NASA, ranking the exploration of Europa as a mission with the highest priority. Since then, NASA has been working on a mission to the icy moon of Jupiter. In 2017, the mission was officially named Europa Clipper after several years of unofficial use of this nickname by researchers and the media. According to NASA, this mission, which is expected to launch in the 2020s, possibly in the late decade, will perform around 40 to 45 flybys of Europa with a spacecraft. On board, there will be 9 scientific instruments, including cameras and radar, to peer beneath the ice and attempt to determine its thickness, a magnetometer to measure the magnetic field and, consequently, the salinity of the ocean, and a thermal imager to search for signs of eruptions. The altitude of the flights will range from 25 to 2,700 kilometers, which leads to flybys passing through Europa's radiation-heavy zone, making it challenging for the spacecraft to survive. Therefore, withdrawing the spacecraft from this zone will extend its service life and facilitate data transmission back to Earth. One of the priorities of the Europa Clipper mission will be to continue observing the plumes, provided their existence is confirmed and they are associated with the subsurface ocean. Studying their composition will help scientists explore the potentially habitable chemical environment of Europa, minimizing the need for drilling through layers of ice, according to a NASA statement. The European Space Agency is also planning a mission to Europa and 2 other moons called JUICE and Moons Explorer. It is expected that the mission will be launched in April 2023 and reach Jupiter's orbit in July 2031. Once it reaches Europa, the mission will study organic molecules and other components that could make the moon habitable. Additionally, the spacecraft will investigate the thickness of the icy crust, particularly over any active regions it encounters. Jupiter is enormous. It could fit 1,300 Earths inside it. It's extremely hot here, with the planet's core temperature reaching almost 24,000 degrees. Unfortunately, we can't land on Jupiter. It's a gas giant with no solid surface, but it is possible to descend deeper into Jupiter's atmosphere. Look at those dense brown, yellow, red, and white clouds. It's because of them that the planet appears so colorful and striped. If we descend to the planet's center, we can see how its atmosphere, composed of hydrogen and helium gas, turns into a liquid, all thanks to the immense atmospheric pressure around Jupiter's core. There are many mysteries swirling around. Scientists have not yet determined whether it is a molten sphere, a dense liquid, or a solid rock. It is 14 to 18 times larger than Earth, regardless. In any case, the main goal of our journey is not to explore Jupiter. We came here to see the Great Red Spot, a massive atmospheric vortex raging in the planet's southern hemisphere. It is nearly 8 kilometers taller than the surrounding clouds and almost 1.5 times wider than our planet. In 2017, space probes such as Voyager and Juno gathered a lot of information about the Great Red Spot. It turns out to be a monstrous storm that extends 322 kilometers deep into the planet's atmosphere, which is 30 to 100 times deeper than any ocean on Earth. However, these data might be imprecise, and the origins of the vortex could be even deeper. The Great Red Spot is colder than the rest of the atmosphere. The temperature on Jupiter's upper cloud layers is minus 148 degrees Celsius. On the other hand, the closer to the core, the hotter it gets. It is strange that the high temperatures observed on Jupiter were registered in the atmosphere directly above the Great Red Spot. There, the temperature reached 1300 degrees Celsius, higher than the temperature of lava on our planet. Astronomers believe that turbulence caused by the vortex can lead to gravitational and sound waves, which may be the cause of overheating. However, at the bottom of the vortex, it is warmer than at the top. People have been observing the vortex on Jupiter for over 150 years. Astronomers once predicted that it would gradually slow down, shrink, or disappear completely, but that turned out not to be the case. After analyzing all the data obtained with the help of the Hubble Space Telescope, scientists were perplexed when they discovered that the winds at the outer boundaries of the vortex gained speed. The changes amounted to no more than 2.5 kilometers per hour over the course of one Earth year, which is very small. However, despite this, it still holds great significance. The wind speed at the edges of the vortex can reach an incredible 645 kilometers per hour, faster than a tornado on Earth. But it turns out that if you were in the center of the Great Red Spot, the spectacle would not impress you because the wind speed there is much lower. Scientists faced numerous challenges when trying to unravel the mystery of the Great Red Spot. It is unknown what fuels this vortex. It may be something within the planet itself. Being a gas giant, Jupiter lacks a solid surface, so there is no friction, the only phenomenon capable of weakening the vortex. The hot gases in the planet's atmosphere are constantly in motion, rising, descending, and swirling, similar to Earth where colder and warmer air masses mix and merge, forming giant storms. Astronomers believe that at some point, several massive storms could have merged to create the Great Red Spot, and now it constantly absorbs cold gases from below and hot gases from above. Furthermore, the vortex can absorb smaller vortices, making the Great Red Spot even stronger. Unfortunately, due to the dense clouds on Jupiter, astronomers cannot see what is happening in the lower layers of the planet's atmosphere. Scientists have long pondered what might be hiding beneath the Great Red Spot. A massive volcano is unlikely, as Jupiter is primarily composed of gases and lacks a crust that could crack, allowing lava to erupt. There are several theories about why the vortex has such a color range. It varies from whitish and pale pink to bright orange and brick red. Scientists believe that the answer lies deep beneath the Great Red Spot, closer to the planet's surface. A colorless layer of gas can likely react to ultraviolet radiation from the sun, resulting in a red color. However, this is currently just a theory. Hey, you've also thought about it, right? Jupiter isn't the only star with a giant vortex. Another one, the size of our Earth, is raging on Saturn, and it's called the Great White Spot. How original. Vortices have a tail of white clouds surrounding the entire planet. This phenomenon occurs approximately every 30 years. This vortex actually starts as a spot, but then it expands more and more. Astronomers have discovered that the Great White Spot is a massive thunderstorm system. The size of the storm can produce lightning flashes more than 10 times per second. But the main mystery of the Great White Spot lies in its energy source. Some scientists believe it can draw energy from the sun, while others claim that the structure of the thunderclouds only makes sense if there is an internal heat source powering the winds. Nevertheless, powerful vortices exist on different planets in the solar system, and ours is not the only one. Let's move to Pluto, the largest of the known dwarf planets in the solar system, and explore its atmosphere. It extends high above the planet's surface and contains more than 20 layers of icy formations. By the way, the Moon also has an atmosphere called the exosphere, composed of helium, neon, and argon. It is about 10 trillion times thinner than Earth's atmosphere. A black hole is a place where gravity is so strong that even light cannot escape. However, sometimes they can behave like enormous galactic volcanoes. Black holes can ignite like volcanoes, but instead of spewing lava, they generate an enormous amount of energy. As a result, they leave behind huge voids in the surrounding gas and material. Recently, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that ignited many, many years ago. This event occurred in a galaxy cluster located approximately 390 million light-years away from Earth. The remaining crater can accommodate 15 Milky Way galaxies. It's hard to believe such a thing. During space travel, think twice before landing on unknown planets, or else you might find yourself in a place like Kepler 141b. This planet is outside our solar system, and at first glance it doesn't differ much from Earth. There are liquid oceans that evaporate, forming clouds instead of condensing. On this planet, rain falls not from water but from stones. The surface of this exoplanet is covered with lava seas that reach depths of tens of kilometers. During the day, the temperature on 141b reaches nearly 28 degrees Celsius, which is enough for the magma in the oceans to evaporate into the atmosphere. Then, supersonic winds with speeds of up to 1.5 kilometers per second transport the vaporized rock to the planet's night side. The evaporated magma cools down, turns liquid again, and falls as a stone rain. On Saturn's moon Titan, there are both land and seas, as well as 6 elements that are abundant, so scientists believe that there is a high possibility of life on Titan. Let's take a closer look at the possibility of life on Titan. Titan, a moon of Saturn, is huge, second only to Ganymede in size among moons in the solar system. With a radius of about 2,575 kilometers, it is 1.5 times larger than the Moon and about 40% the size of the Earth. Although it can be observed from Earth, it is difficult to observe Titan's interior properly because of its thick atmosphere. Therefore, Titan was a mysterious celestial body shrouded in mystery for a while. However, in 1997, the European Space Agency and NASA launched the Cassini spacecraft to explore Saturn and its moons, and this spacecraft visited Titan. Hundreds of photos and atmospheric composition analysis were sent to Earth, revealing its identity. The image of Titan sent by the Cassini spacecraft was quite ordinary, with mostly wide plains and sand dunes created by the wind in low-lying areas. There were even mountains as high as 3,330 meters. At first glance, these photos looked like hazy days on Earth with dust or fine dust. Clouds were also observed in the sky of Titan. Weather phenomena occurred on Titan similar to those on Earth, with rain falling and lakes forming on the plains, and even seas forming in low-lying areas. Like Earth, liquid circulation also occurs on Titan. With this information, it seems that the speculations of Professor Carl Sagan, who was always right about the possibility of life on Titan, were not true. Or perhaps humans on Earth will one day be able to live on Titan. Because it is located as far as 1.4 billion kilometers away from the Sun, it doesn't receive enough solar heat properly. So as it turns out, the average temperature of Titan is minus 179 degrees Celsius. Titan can be called a supergiant freezer. Normally, if the temperature is minus 179 degrees, all the clothes on this satellite should freeze. Clouds 3 and oceans confirmed through Cassini 5 have a significant discrepancy with what we usually know. The hills on Titan were formed by completely freezing, and the seas on Titan were made up of methane. Also, the clouds were not white clouds gathered by water vapor like Earth, but had a murky appearance. When we only saw Titan in photos, we thought it could be habitable, but it's definitely not a place with a climate like Earth. Even though our environment is like this, scientists' opinions were very positive when Titan was discovered, except for Earth, as it is the only place where liquid is maintained on the surface in a stable way. This is the first celestial body that we confirmed, and there might be life forms here. Also, thanks to the layered structure of Titan, there are winds and rain, making it an optimal place for life. Now let's take a closer look at Titan. Titan has a dense, murky atmosphere. The atmospheric pressure is about 1.45 times that of Earth, and about 98% of the atmosphere is made up of nitrogen with trace amounts of methane. Interestingly, aside from Earth, Titan is the only celestial body in the solar system with nitrogen. Scientists say that Titan's nitrogen-rich atmosphere is very similar to the primitive atmosphere of Earth about 3.8 billion years ago. If we can analyze Titan's atmosphere, we can learn more about the changes in Earth's atmosphere. Currently, nitrogen is the most abundant gas in Earth's atmosphere, accounting for 78%, followed by oxygen at 21% and argon at 0.90%. These atmospheric compositions are present on Earth. However, these ratios have changed slightly over the course of several hundred million to billions of years. Titan's dense nitrogen atmosphere causes a greenhouse effect, which maintains a high temperature despite receiving very little solar radiation. This keeps methane in a liquid and gaseous state. If Titan did not have nitrogen, all of its methane would have frozen, and Titan itself would have become a completely frozen celestial body. Amazingly, the study of Titan has even led to the discovery of some unique molecules that are essential for life formation, such as cyclopropanyl, which is composed of carbon and 2 hydrogen atoms. This molecule is an important building block for life and also serves as food for other organisms. Although cyclopropanyl is difficult to pronounce and understand, it is a crucial substance that cannot be overlooked in the formation of life in the universe, and has been observed occasionally in interstellar matter. However, except for Titan, there has been no discovery of such compounds in other celestial bodies, so it's really amazing and remarkable. Cyclopropanyl, composed of 2 carbon atoms and 2 hydrogen atoms, has been discovered in Titan's atmosphere using the ALMA radio telescope by NASA's research team. The discovery of this molecule, which is difficult to pronounce and has caused quite a stir, is an essential component of the formation of living organisms and can also serve as food for other organisms. Although it has occasionally been observed among interstellar substances in the universe, it has never been found in any other celestial body until now, except for Titan. This is really remarkable, especially considering that it has only been found in 2 places, Titan, which is similar to the primitive Earth environment, and some other celestial body. Moreover, many benzene compounds have also been detected. These compounds play a role in the formation of complex organic matter. In addition, there are other compounds such as argon and carbon monoxide in the atmosphere of Titan, which is conducive to the formation of organic matter during its evolution. It is an environment where organic matter formed during its evolution is falling like light snow. There is one more fact to note about Titan. It is that 82% of its surface is covered with organic matter. According to Dr. Rosalie Lopez, a NASA scientist, more than 82% of Titan's surface is composed of organic matter that has fallen from its atmosphere and has been transported by winds. This means that Titan's organic matter is very abundant, which suggests the possibility of the existence of living organisms. This is an exciting discovery that raises the possibility of the existence of microbial or other life forms. If such life forms were present, there would be abundant sources of food. Another important fact is that there are oceans on Titan. Prior to this, lakes were discovered on Titan, but now it has been revealed that there are oceans as well. If the liquid in these oceans seeps into the subsurface, it could provide sufficient conditions for the birth of life. While this liquid is not water, Titan is the only celestial body in our solar system, besides Earth, where liquid exists on the surface. Scientists have found that Titan's oceans are deeper than previously thought. In fact, during an investigation of one of Titan's seas, Kraken Mare, the equipment that was used to probe the sea was limited by its technological capabilities and was unable to reach the bottom, which is at least 300 meters deep. This is more than 7 times deeper than the average depth of the West Sea, which is approximately 43 meters. In addition, there are geological activities like volcanic activities in Titan, and if such visual activities occur, an ecosystem ranging from microorganisms that use organic matter around the hot springs as food to predators on top of them may have formed. From the beginning, including Titan, organic matter is very abundant, so if miraculously some organisms were discovered on Titan, an ecosystem of organisms and their mothers could have already formed in Titan's seas. The most important clue is this. Recently, it was found that after hydrogen descends from Titan's atmosphere, it disappears from the surface, according to the data collected by Cassini. Some scientists at JPL are claiming that this may be the result of primitive life breathing in and consuming material on the surface. However, Titan's flowing liquid is methane, so if life is actually emerging and surviving here on Titan, the living organisms of Titan may be based on methane. Scientists are looking at Titan's existence of life with a very positive outlook. NASA has started the Dragonfly project to explore the seas of Titan. They will fly a kind of drone powered by a blue-tone fuel to observe various terrains of Titan. The Dragonfly project is expected to launch in 2026 and arrive near Saturn in 2034. They plan to use a parachute to land on Titan when the weather is favorable, and then switch to flight mode to explore and collect samples. Previously, Genius explorations were mostly conducted using ground vehicles, but this method had limitations in mobility, so the goal is to easily explore multiple locations. I will go crazy with my child's drone to explore. The target distance and time for the exploration are about 2 years, 7 months, and approximately 175 kilometers. This distance is twice the distance traveled by all Mars rovers so far. NASA hasn't made a final decision yet, but they say they could send a 1-ton submarine to Titan. The purpose would be to explore the largest Kraken Mare Sea on Titan, which has a fairly deep depth from the beginning. A submarine would be 10 times better than a drone to explore it. If we explore the liquid methane ocean with a submarine, we could thoroughly examine the ocean floor. What do you think about the possibility of life on Titan, Saturn's moon? If you are interested in astronomy and often watch movies about space, then you probably know the most important question that bothers enthusiasts of this topic. Are we alone in the universe? And no matter what anyone says, there is still no definitive answer to it. Despite the fact that the raw materials for life are everywhere and planets are abundant, there is not a single known world other than Earth that could confidently be called a home for life. However, there is hope that the search for the first signs of extraterrestrial life will be successful in the near future on exoplanets orbiting distant stars. There may be life. By measuring the spectral characteristics of their atmospheres using transit spectroscopy, or in the near future through direct imaging, we may be able to confirm this. But why look so far, when in fact, it's possible that it exists right here in our solar system? Mars, Titan, Europa, Enceladus, Ganymede, Pluto, there are plenty of candidates. Not long ago, on Venus, of all places, who would have thought phosphine was discovered? This exciting discovery is significant for science, chemistry, and the very question of life in the universe. In many ways, Venus is the most Earth-like planet in the solar system. With a comparable mass and radius, it could have been watery, moist, and equally conducive to life as Earth for hundreds of millions or even billions of years. However, today its surface is inhospitable and scorching, with a thick sulfuric acid-rich atmosphere. But nonetheless, it offers a wide potential for chemical processes. Phosphine, at first glance, may not seem like a remarkable molecule. Let's first recall the most abundant elements in the universe: hydrogen and helium, followed by oxygen, carbon, and nitrogen. These elements are formed in the previous generations of stars and are found in the atmospheres of rocky planets in our solar system. Systems, including Venus, Earth, and Mars, were dominated by these elements, likely containing significant amounts of water, methane, and ammonia. But it's not all that simple. For example, silane is analogous to methane, hydrogen sulfide shares many properties with water, and ammonia has many similarities with a spin. Here on Earth, silane is a colorless, easily flammable, and toxic gas. However, it is also naturally produced by anaerobic bacteria in conditions of oxygen deficiency. In a new study, a group of scientists from various fields came together to publish a series of 3 articles announcing an impressive discovery. In the upper layers of the hazy atmosphere of Venus, reaching its peak in the mid-latitudes, phosphine was detected. And this is not a mere assumption. Without a doubt, this radio signal was observed by 2 different observatories independently. They both observed the same absorption feature of equal strength at the same wavelength. Venus is a well-known natural emitter, and phosphine creates a distinctive dip in this emission due to its presence. This scientific discovery itself is very significant, but it tells us very little. Phosphine exists in the temperate zone of Venus, or in its vicinity. The temperature and atmospheric pressure are comparable to those found on the surface of the Earth, despite the hazy and dense atmosphere rich in sulfuric acid. The detected phosphine signal is strongest in the mid-latitudes, with a concentration of around 20 parts per billion, which is about 0.02% of Venus's atmosphere. Molecules in the Venusian atmosphere have many different wavelengths at which they can absorb light, which means that numerous different signatures can be observed. If we need to quantitatively assess the presence of this molecule's property in the Venusian atmosphere, currently there is only detection at one specific wavelength. However, if there are several other wavelengths observed, they will provide much more information. So far, the presence of phosphine has been established, but the next step will be understanding its origin there. For all of humanity in general, in our long history of space exploration, there is not so much a lack as a shortcoming that needs to be addressed. When an unexpected signature is unexpectedly discovered, an explanation that goes beyond our current understanding, the wildest conclusion is immediately drawn: extraterrestrial life. For example, about 40 years ago, carbon monoxide was discovered in the atmosphere of Titan, and its chemical composition could not explain this very signature. However, about 10 years later, the mystery was solved. It was found that Enceladus, an icy moon rich in geysers, was adding water to Titan's atmosphere. Since 2004, methane has also been detected on Mars, raising suspicions of the existence of something alive. But now, thanks to the Mars rover Curiosity, we know that methane exhibits a seasonal nature and even changes within a single day. Many are searching for a biological explanation, but in this case, a chemical origin seems more likely. We can also recall the mysterious star, Tabby's star, and the megastructures observed around it. Extraterrestrial megastructures are undoubtedly the most memorable headline, but there are many stars with peculiar dimming. Today, explanations involving these megastructures as alien constructions are considered far-fetched. It's not difficult to explain why we jump to such conclusions, but it takes time. And I believe that with time, it will pass. So it's better for us to return to phosphine. The surface of Venus, like many other rocky bodies in our solar system, contains a large amount of phosphorus in the form of various phosphates. However, the conversion of these phosphates into phosphine is a complex task. One of the scientists working on this discovery, Dr. William Baines, described in detail 3 possible pathways for this conversion. Photochemical processes induced by solar radiation in the upper layers of Venus's atmosphere, chemical processes resulting from thermodynamic effects in the lower layers of the atmosphere, or geochemical processes resulting from chemical reactions on the surface. By using the most complex chemical modeling and considering a range of exotic scenarios, he found that none of these options fit. They all produce too little phosphine to explain the observed signal. And as you may have noticed, the scientist mentioned 3 options, but one is missing. Could phosphine be produced through a biological pathway? In fact, if we look at how phosphine is produced on Earth, it is exclusively through biological means. On Earth, It is a natural process carried out by bacteria in an anaerobic environment or artificially produced by humans. However, there is still much we don't know about its natural production, including which organism actually produces it. Presumably, a form of E. coli is involved in its biochemical pathway. Can this pathway be reproduced non-organically? Meanwhile, phosphine has been found abundantly throughout the universe in large quantities. It exists in the atmospheres of gas giants like Jupiter and Saturn, and it is found both as a standalone molecule and associated with other molecules around carbon-rich stars and even in the interstellar medium. But what is the reason for its appearance specifically on Venus? One thing can be said for sure: it is definitely related to an unknown chemical reaction. Some form of chemistry, in one way or another, produces these numerous phosphine molecules. This unknown chemical reaction could have one of several causes. It could be easily associated with a geological process, purely chemical, or even biological. In principle, it could be any of them, but still, betting on biology is like buying a lottery ticket and hoping to hit the jackpot. If life produces this phosphine, it must somehow survive by reacting with sulfuric acid, and it would require the microorganisms producing phosphine to be extremely abundant and efficient. They would need to occupy the entire volume of Venus's atmosphere in the moderate zone and work with almost maximum efficiency to account for this signal. It is not impossible, but it is a highly unusual scenario. So if phosphine is not a product of life on Venus, then the intriguing question arises: what is the actual source of phosphine? It cannot be produced in the same way as on Jupiter or Saturn, where its production depends on the strong pressure created by the dense hydrogen atmosphere. However, ruling out all possible chemical reactions is also not possible. What are the densities of different gases in Venus's atmosphere, depending on altitude and latitude? What is the distribution of phosphine? What are the precursor molecules or the molecules involved after its breakdown? And how the presence of various sulfur compounds, which exist in abundance in Venus's atmosphere, changes the reaction equations that we expect. There is still much we do not know about our neighboring planet, and only after answering these questions can we discuss the biological origin, that is, life. To understand the origin of phosphine, it will require not only new qualitative observations, but also additional missions to explore Venus. Perhaps that is the only way to reach the truth, and maybe that's why all this buzz was created. I intentionally didn't rush with a video on this topic, although I'm probably obligated to cover it on our channel. After all, it's practically one of the biggest events in cosmology this year. But the more I read about this subject, the more I thought that there have been relatively few missions to Venus. The near future was planned for Mars, Titan, Europa, Enceladus, and wherever else. Maybe it was necessary to pay more attention to Venus, but there simply wasn't a more successful alternative. But now, after the sensation with phosphine, you can see that things are already stirring up. There are missions planned for Venus. In general, agree that there is something to it. Even Dmitry Rogozin, the head of Roscosmos, referred to it as the Russian planet Venus. But returning to our topic, claims that phosphine is a sign of extraterrestrial life are at best wild speculative ideas, and at worst, simply fiction. It's an astonishing discovery, but it doesn't necessarily mean there is life on Venus.